Good morning, dear students. My name is Ferhan Mazher, and today is 19th February 2021. And right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 5054. And we are doing with this is O3 class, and we are practicing and past papers, and we are trying to prepare our students for the upcoming mocks exam. Today we have set our hearts on the winter 2016 2-1 paper. It's a theory paper. We call it the paper 2. And in this session, we are going to solve the section B of this paper. So on your screen, you can see this is winter 2016 2-1, physics 5054, section B, question number 8. He says the sodium 24 and sodium 23 are two of the isotopes of sodium. Sodium 24 is a radioactive isotope that emits beta particles and gamma rays as it decays. The nuclide notation for the sodium isotope 24 is sodium 2411. Describe the composition and structure of the neutral atom of the sodium 24. You see, the question is very simple. He wants you to, it's kind of chemistry question, and he wants you to write down the structure of the sodium 24. So in the nucleus, the sodium 24 will have 11 protons, and if you minus 24 minus 11, then it will be, I think, 13 neutrons. There will be 11 protons and 13 neutrons in the nucleus, and there will be 11 electrons orbiting the nucleus. So kindly write this answer in your booklet. I hope you have this booklet with you.
सर ये कौन सा पेपर कर रहे हैं?
We are doing winter 2016 2-1. Your booklet, the top of your booklet will say zone 1. It's winter 2016 2-1. We are doing the section B of this paper. Javeria, do you have this booklet with you?
Yes, sir, I have.
Yeah, just open that paper.
Okay.
Because in this you will have to write the answers in your booklet also.
Yes, sir.
Okay. So he's asking us to write down the structure of a neutral atom of sodium 24. So sodium 24, it has 11 protons and 13 neutrons in its nucleus. And there will be 11 electrons. They will be orbiting around the nucleus in their shells. You can write this answer. So three mark question. You have written your answer?
Yes, sir.
Okay, can you read your answer?
Yes, sir. I have written that sodium isotope will have 11 protons in nucleus, 13 neutrons, and 11 electrons will be orbiting the nucleus.
Okay, so marking scheme is also showing on your screen. You can see that saying that 11 protons and 11 electrons, that will give you 1 mark. 13 marks are for telling that how many neutrons are in the nucleus, and the 1 mark is for telling that the neutrons and the protons will be in the nucleus and the electrons will be in the orbits. Javeria, are you done with this?
सर मैं पेपर ढूंढ रही हूँ.
It's winter 2016 2-1. On the top of the booklet, it should be saying zone 1.
Okay. मिल गया सर.
Okay.
Section B.
Okay. You write the answer. In the meanwhile, we'll go to the next question. He says, state how the composition of a nucleus of sodium 24 differs from the composition of a nucleus of sodium 23. So you see that both are the isotopes of sodium. The only difference is they both in the nucleus will have the same number of protons, and but there will be one difference. The number of neutrons will be different. In the sodium 24, there will be 13, neutrons, but in sodium 23, there will be only 12, 12 neutrons. Can you write this answer?
Yes, sir.
Okay, so go on.
I have written, sir.
Yes, kindly read that.
Number of neutrons in sodium 24 will be 13, whereas number of neutrons in sodium 23 will be only 12.
And they both will have the same number of protons.
Okay, sir.
But here he asked for difference. Your answer is good. Should we move to the next question?
Yes, sir.
Muskan, your answer was right. He only asked for the difference.
Okay, sir.
A nucleus of sodium 24 decays. It emits beta particle and produce a nucleus of an isotope of magnesium. State the name of the particle that is identical to a beta particle. Beta particle has a negative charge and it's like an electron. Only you have to state. Beta particle is like an electron. The marking scheme is also on your screen. Beta particle is like an electron.
Sir, I have written the answer.
Okay. So, should we go to the next one?
Yes, sir.
Complete the nuclide equation for the emission of a beta particle by sodium. You see in the beta particle here on this right side of this equation, on the beta particle here downstairs, you will write -1. On your booklet right here where that hand is pointing, -1. And on the top of this B upstairs, you write 0.
Okay, sir.
Okay. So here, whenever a beta particle is given out, remember these words. Whenever a beta particle is given out, the number of protons or the atomic number should increase by 1. Okay. So here downstairs with the Mg, you write 12 and the mass number do not change. That still remains 24. Do you understand?
Yes, sir.
Yes, sir.
Whenever a beta particle is given out, the proton number increases by 1 and the mass number do not change. And another extra thing which you should remember is that the number of neutrons will decrease by 1, but the mass number will not change. Proton number increases by 1, mass number remains same, number of neutrons decreases by 1.
Okay, sir.
Okay, so when it decays, sodium 24 also emit gamma rays. State what are gamma rays. Gamma rays are, you remember, they are the part of electromagnetic spectrum. When we studied that chapter, electromagnetic spectrum, Ronald McDonald is very ugly except Gary. Gamma rays is part of the electromagnetic spectrum. They are transverse waves, and they have very high frequency, and they have a lot of energy with them. Let me read. This is a 2-mark question. Let me check the marking scheme also. You see on your screen, the marking scheme for the C part is showing electromagnetic radiation or rays or waves with very high frequency. They also have very high energy, and the wavelength is very short. Kindly write this answer in your booklet.
Done, sir.
Javeria, will you like to read your answer?
Yes, sir. Gamma rays are the part of the electromagnetic spectrum. They are transverse wave and they have high frequencies and short wavelength.
Good, very good.
I have also written.
Okay, read your answer.
Gamma rays are electromagnetic radiations. They are transverse rays and they have high energy and high frequency.
Okay, good. Now, the D part, figure 8.1 shows a beam of beta particles and a beam of gamma rays entering the electric field between two oppositely charged particle plates. So, the question is on the figure 8.1, draw the path of the beta particles in the electric field between the charged plates. On figure 8.1, draw the path of the gamma rays in the electric field between the charged plates. I said particles, it's plates. Explain why the path taken by the beta particles differ from that taken by the gamma rays, and it's a 1-mark question. Okay, let me copy it from here. Take out the snipping tools. Okay, and we will copy from here, and we'll take it in the, so I can show you how you will draw this in your, okay. Wait. AI. Okay, let's make putting it here. Okay. So the gamma rays, because they do not have any charge on them, so the electric field will have no effect on them. So they will go straight without any kind of deflection. You understand? Do you understand?
Why,
Because
sir?
the gamma rays are neutral, they don't have a charge on them. So
Okay.
when they pass through the electric field will have no effect on them. So they will go undeflected, they will go straight. Okay, the next thing is that we have a beta particle, and the beam of beta particles is passing through these plates, and you know the beta particles, they are like electrons, they are negatively charged. So when they will enter into the electric field, because they are negatively charged, they will be attracted to the positive plate. So what will happen from here? They will be attracted towards the positive plate. So they will go like this. The beta particles, because they have negative charge on them, they will be attracted towards the positive plate. Gamma rays, on the other hand, they do not have any charge on them. They are neutral. So they go straight undeflected through both the plates. Between the both plates, they go undeflected. So these two you have to draw on your booklet. And the third part was, is this clear?
Yes, sir.
Okay, let me show you the marking scheme. So on your screen, the marking scheme for the D part is showing the path curving upwards. That carries 1 mark. Path continues in straight line, 1 mark. And beta particles charged or gamma rays uncharged. So these are the 3 parts. And can you write that answer? and then just read the answer for me. When you have written your answer, kindly let me know.
Okay, sir. Done, sir.
Okay. So kindly read your answer.
Beta particles are charged, that's why its beam attracted to positive terminal and curved upward.
Okay.
But
So the
gamma
answer is half right because you said the beta particles are charged. Say beta particles are negatively charged. Add the word negatively.
and I have also written that gamma rays are uncharged, that's why its beam continues in straight line.
Done,
Right?
sir.
The answer is right, but only add that the beta particles are charged before the word charged, right? Negatively charged.
Okay, sir.
Sir, may I read my answer?
Yes, yes, better.
Beta particles path is curving upward, but gamma rays path continues in straight line as beta particles are negatively charged, but gamma rays are uncharged.
Yeah, that's right. Good. So we can start the next one. Sodium 24 is sometimes used in diagnosing medical conditions. The half life of sodium 24 is 15 hours. Explain one reason why a half life of 15 hours makes the isotope suitable for use in the human body. You see, if the half life is just 15 hours, it will provide enough time for the doctors or to the medical professionals, so they can do their diagnostic tests. And plus it's not that long. It's not that long. So what happens, the man or the patient, uh, in which you have injected this, he will not remain irradiated for a long time. Let me show you the answer on the marking scheme. You see, there are two things basically. The 15 hours time is long enough to take the measurements to do the diagnostic tests on the patient. So doctor will have enough time. 15 hours is enough time for the doctors to do all the tests they want to do. And this is not that long because it's good that it's not too much long because because you inject this thing into the patient. So you see, the patient will be very radioactive. So we don't want the patient to be very radioactive for a longer time. The word we use is irradiated. You can see the spellings also on the screen. The patient is, this is short enough so that the body is not irradiated for a longer time. So you have to write both the things. If you have the space in the lines, write both the things. Let me check the answer. Question, sorry. In the question, he said, explain one reason. Okay, you have to only write the one reason. You only have to write one reason, but we know both the reasons. When he asks you to write one reason, you write one reason. But for our own understanding and for learning purpose, we describe both.
Done, sir.
Done. Okay, kindly read your answer.
15 hours time is long enough for doctors to carry out tests and take measurements. It is also short enough so the body is not irradiated for a long time.
So, okay. So, how many lines this answer took?
4 lines.
Okay. So, you don't have to use extra lines.
Yes,
Done,
sir.
sir.
Okay. So, Javeria, kindly read your answer.
15 or time is enough time for the doctor to take measurements and the body is not irradiated for a long time.
Very good. Very good. The perfect answer. Okay. The question number 9 is on your screen. The primary coil of a transformer is connected to a 230-volt AC main supply. Describe how the transformer operates. You remember yesterday, Javeria, you was there in the class. We did the question
Yes,
on
sir.
transformer. Yeah. But here you only have to describe that how the transformer operates. Okay. So the how the transformer operates, the transformer has two coils and they are wound on a iron core. And what happens in the primary coil? We provide alternating current. And due to this alternating current, the electromagnet which is formed on the primary coil, its magnetic polarity is also continuously changing due to the alternating current. So that the magnetic field lines of that electromagnet through the iron core, they pass through the secondary coil. And because those electric field lines, they are changing in direction and magnitude as well, due to that changing magnetic field, EMF is induced in the secondary coil. So this is how the transformer operates. Can you repeat this? Do you understand this thing?
नहीं सर समझ नहीं आई.
You see, we have a in the transformer, we have a primary coil and we have a secondary coil. They
जी.
both wound on a iron core. If you remember that diagram which I just showed you
Yes, sir.
class, we draw on a paper. Okay, so in the primary coil, you provide alternating current, AC current. So the primary coil, when the current will pass through it, will become electromagnet. Because the current you are providing is alternating, which means its direction is continuously changing. So what happens? The electromagnet which is formed on the primary coil, its polarity means north pole, south pole, they are also continuously changing. So the magnetic field lines or magnetic flux of that electromagnet on the primary coil, its magnetic lines through the iron core, they are passing through the secondary coil. Because those electromagnetic lines are changing, that's why, or magnetic flux is changing and it's passing through the secondary coil. EMF is induced in the secondary coil. This is how a transformer works. It's a 3-mark question. Can you write it now?
Yes, sir.
So you see there are 3 marks. One is magnetic field should be mentioned. The second number is for changing alternating current should be mentioned. And that should be mentioned that the magnetic field is changing. And the third number is for telling that the current or EMF will be induced in the secondary coil. Kindly try to write this answer and then we will make corrections in it.
Okay.
Okay. The marking scheme is also showing on your screen. Question number 9A part. The marking scheme is showing on your screen. When you are done, kindly let me know.
Okay.
Yes, sir.
नहीं थोड़ा कर. You should mention that there are two coils, primary coil, secondary coil. They are wound on iron core, and the primary coil is like input, and we provide it with the alternating current. Due to this, electromagnet is formed on the primary coil, and due to the AC current, the magnetic field is changing in direction and in the magnitude both. The magnetic field lines through the iron core, they are passing through the secondary coil. And because those magnetic lines are changing, the EMF is induced in the secondary coil. That's how a transformer works.
सर मैग्नेटिक फ्लक्स प्राइमरी कॉइल से आ रहे.
Yes, because the electromagnet is the primary coil, is on the primary, and its magnetic lines or magnetic flux is passing through that iron core and is passing through the secondary coil also. So
Done.
because it's changing, the EMF is, because it's changing. It's very important to say, because those magnetic field lines are changing. That's why the EMF is induced in the secondary coil.
Done, sir.
Yes, kindly read your answer.
I have written there are primary coil and secondary coil. They both mount on iron core.
Yeah.
AC current is provided to primary coil. Current will pass through primary coil. It will become electromagnetic. Its direction will change and its polarity will also change. Magnetic field lines on primary coil through iron core passes through secondary coil and EMF is induced in secondary coil. That's how transformer operates.
Okay. So a few things which I can notice is that the current you provided, you should mention that it's alternating. Okay. It's
Yes,
particularly
sir.
important to you say alternating current. Okay. The second thing, the primary coil becomes an electromagnet. The word is electromagnet. The second and one very important thing is you need to mention that the magnetic lines which are passing through the secondary coil, they are changing. That's why the EMF is induced.
Done, sir.
Okay, Javeria, kindly read your answer.
Transformers has two coils, secondary and primary. In the secondary coil, AC current is passing into
Stop,
primary
stop, stop,
coil
stop, stop,
and
stop,
magnetic flux is
stop.
passing through secondary coil. And because magnetic field
Yeah,
lines are negatively charged, EMF is induced in the secondary coil.
Okay, so listen carefully. Listen me carefully.
Okay.
There is a secondary coil and there is a primary coil.
Yes.
In the primary coil, we provide alternating current. You wrote in the secondary coil, we provide. No. cut this secondary coil thing, write
Okay.
that we provide alternating current to the primary coil,
Okay, sir.
and then the primary coil will become electromagnet, and
अच्छा.
its magnetic field is changing due to alternating current. And those its magnetic lines through the iron core pass through the secondary coil, and because they are changing, the EMF is induced in the secondary coil.
Okay,
Make
sir.
this and then read your answer once again.
Okay, sir.
It's a very, very important answer. It's usually come in paper. You will find this thing in many, many papers. So if you learned it today, it will be good.
इलेक्ट्रोमैग्नेटिक प्रोड्यूस हो रही है सर प्राइमरी कॉइल में.
Yes, the primary coil will become an electromagnet.
Okay. That's sir.
Yes. Read.
Transformer has two coils, secondary and primary. The primary coil will become electromagnetic coil. Uh, AC current is passing into the primary coil and magnetic flux is passing through the secondary coil, and because magnetic field are changing, EMF is induced in the secondary coil.
Okay. So it's better now. Okay.
Okay.
Are you looking at the are you looking at the marking scheme as well? The marking scheme is in front of you.
Yes, sir.
Okay. So we are moving to the next part. The output voltage of the transformer is alternating and cannot be used directly as a DC power supply. In the space below, draw the symbol of a circuit component that allows the current to pass in only one direction, and state the name of the component. For this purpose, we use a diode, and the symbol of the diode is on your screen. You can see that. You have to write the name of this component. It's diode, and this is the electric symbol for this, circuit symbol for the diode. You have to draw this symbol and you have to write this name, diode. Diode only allows the current to flow in one direction. And if you are talking about the conventional current, if the current will be along this arrow, then it will let the current pass. And if the current will come in the opposite direction, it will not let the current pass. Kindly draw this symbol and write the name.
Done.
You're done. Okay, good. Good. So we move to the next part. It says figure 9.1 shows a DC power supply being used to charge a rechargeable battery. The rechargeable battery is in series with the DC power supply and a 5.2 ohm resistor. The EMF of the power supply is 5 volts. What is meant by the EMF? It's a definition. EMF. What is meant by the EMF? You can say you can use
Electromotive.
yes, electromotive force. And the definition is the amount of work done by the power supply to move 1 coulomb charge in the circuit. This is one definition. The amount of work done, or the amount of work done by the power supply to move unit charge, means 1 coulomb charge in the circuit. Another definition can be that the EMF means the amount of chemical energy converted into the amount of chemical energy, chemical potential energy converted into electric energy, then unit charge flows through the cell.
Done, sir.
So kindly read this. This is a 2 mark definition and a very famous definition.
EMF is the amount of work done by power supply to move 1 coulomb charge in the circuit.
Yes, that's one definition. Yes. You only need to write one. I was telling you the two definitions.
Done, sir.
Yes, Javeria, kindly read.
The amount of work done by a power supply to move unit charge into the circuit.
Yes, that's called EMF. Let us look at the marking scheme as well. What the marking scheme says, it says work done on energy transfer per unit charge or electric energy to other forms or whole circuit or property of supply. So your definition is good for 2 marks. Let's move to the next part. The EMF of the power supply and the EMF of the battery act against each other in the opposite directions in the circuit. The EMF of the battery is 3.7 volt. Calculate the resultant EMF of the circuit. So just minus 5 minus 3.7. You just have to subtract. The power supply is 5 volt. The battery you are charging is 3.7 volt, and they are connected in the opposite. So it will be 5 minus 3.7 volt. So the resultant EMF will be 5 minus 3.7. It will be something like 1.3 volt.
सर इसका कोई फॉर्मूला नहीं है?
Formula is this, that 5 minus 3.7.
Okay.
The EMF of the power supply minus the EMF of the battery which is being charged.
Done, sir.
He says calculate the current in the circuit. You see that the net EMF is only 1.3 volt and the resistance of the circuit is how much? 5.2 ohm. So apply the formula V equals to IR. He wants you to calculate the amount of current V equal IR.
Yes.
Then I will be V divided by R.
Done, sir.
So what's your
सर
answer?
क्या
I
होगा?
divide 5.3 divided by 5.2, so the answer is 0.25 ampere.
V I is equals to V by R, yeah. 3.7 divided by
5.2.
yeah. So the answer will be what is your answer?
0.025 ampere.
Amperes. Okay, that's good. Where are you done?
Yes, sir.
Okay. The next part is the current in the circuit remains constant as the battery is charged. Calculate the charge that passes through the resistor in 1.5 hours. Okay. You remember the formula for the current is I equals to Q divided by T. I equals to Q divided by T. So
Yes.
Q, the amount of charge we want to know. So the Q equals to I multiply T. But you just calculated the value of the I, you will use that. And the time is 1.5 hours. So, but we don't use the time in hours in this formula. The time must be in seconds. So the amount of current, you just calculated in the second part. Multiply 1.5 hours, multiply 3600. Why I'm multiplying with the 3600? Because I want to convert 1.5 hours into the seconds. So it will be 1.5 multiply 3600 multiply the amount of current. It's a 3 mark numerical, very simple.
1350.
And the unit will be coulomb, capital C. It's represented with the capital C, coulomb.
Done, sir.
Juvelia, you got the same answer?
Yes, sir.
Okay. A battery charger, C part. I'm reading the C part now. A battery charger has a plastic casing and a double insulation. The battery charger is not earthed. Explain why it is not necessary for the battery charger to be earthed. Because you see, it has double insulation. Double insulation means the thing is covered in a plastic and then it has a plastic casing over it. So it's the machinery is inside double plastic casing. So there is no chances that because the plastic is insulator, so there is no chance that the live current will leak into its body and any person touching it will be electrocuted. Do you understand what I'm saying?
Yes, sir.
Okay, let me show you the marking scheme as well so you can write your answer. So it says the plastic casing is in electrical insulator and no shock, electric shock is possible. No electric shock is possible because the body of the charger is uh, encapsulated in a plastic body and then plus another second plastic body is over it. So there is no chances because the plastic is insulator. So there is no possibility that the live current will leak or into the body and any person touching it will be electrocuted.
Done, sir.
Finally, write your answer and then just read it.
May I read, sir?
Yes, yes, Betty, come on. Go on.
Because it has double insulation and machinery inside is also double insulated and no electric shock possible.
Okay.
So may I read?
Yes, yes.
It has double insulation and plastic casing and body is under all these casing, so there is no electric shock possible.
Mm. So it has two plastic casings. Okay. There is a plastic casing around the charger, and then there is another plastic casing over it. Okay. So because of two plastic casings, and the plastic is obviously insulator, so so there is no chance that somebody will get electric shock if they touch the body. So no need of earth. Okay.
Yes, sir.
Okay. So we are moving to the next question. Question number 10 is on your screen. A particular type of cooking oil is a liquid at room temperature. Our room temperature, at room temperature, sorry, air is easily compressed, but the oil cannot be compressed. Explained in terms of molecules why the density of oil is much greater than that of a gas. In the terms of oil has higher density. The reason is it has more number of molecules per unit volume. It has more number of molecules per unit volume as compared to gas. That's why it has higher density. Let me check the marking scheme. Molecules, they close together, small gaps between molecules. The gaps between the molecules obviously are smaller as compared to gas. Kindly write your answer and then read.
May I read, sir?
Yes, Peter, yes, please.
Oil has higher densities and has more number of molecules per unit volume as compared to gas.
Yes. The gaps between them, the molecules are all smaller.
Sir,
Yeah.
I have written that its molecules are closer than of gas. It has more number of molecules per unit volume as compared to gas.
Okay. It's good. So we are moving to the next part. He says, explain why. His question is plain in terms of molecules, why the oil cannot be compressed. This is a very famous question, and mostly the students, when they write its answer, it goes wrong. Why we cannot compress the oil and why we can compress the gas? The reason is a particular wording which you have to use, because the repulsive force, you have to mention that the repulsive force between the particles of the oil is very strong. That is why you cannot compress it. The repulsive force, the force of repulsion between the oil particles with each other, is stronger as compared to the gas. The particles also repel each other. So that repulsive force is very strong in the case of oil molecules, I mean. This is a particular wording which you have to use, okay? Marking scheme is also showing on your screen.
Done, sir.
Okay, what you wrote?
The repulsive force between the molecules is very strong as compared to gas.
Okay, so you see, you need to write that the repulsive force between the molecules of oil. Also say of oil.
Okay, sir.
Yes. Muskan, you written your answer.
Yes, sir.
Kindly read.
Repulsive force between oil particles with each other is very stronger than the particles of gas.
Yes, as compared to the particles of the gas. Yes, that's good. Okay, we are going to the next part. Some of the oil is poured into a metal pan. The oil in the pan has a mass 680 grams. The density of the oil is 0.85 gram per cubic centimeter. Calculate the volume of the oil in the pan. You see, the density equals to mass divided by volume. Density equals to mass divided by volume. So volume will be equals to mass divided by density. Volume equals to mass divided by density. So 680 gram divided by 0.85 gram per cubic centimeter. Write
Is
this
equal
thing
to
and get the
800
answer.
centimeter cube.
So what's the answer?
800 centimeter cube.
800 centimeter RS, sir.
Okay, that is good. That is good. You understand this formula?
Yes,
Density
sir.
formula? Okay, yeah, good. Okay. The pan is placed on an electric hot plate as shown in the figure 10.1. Okay. Explain in terms of molecules or free electrons how thermal energy is conducted through the metal base of the pan. So metal base of the pan. So the conduction, you have to explain the conduction. So there are two ways in which the conduction is happening. The molecules at the hotter end, they absorb the heat energy and they start to vibrate vigorously. The amplitude of their vibration increases, so they collide with their neighboring particles or molecules and they make them vibrate vigorously. In this way, the vibrations are passed from one molecule to the other and from other to the next one. In this way, the energy is transferred from the hot end to the cold end. And other method of the conduction is that because it is made of metal, it has free electrons in it. So the free electrons at the hot end will absorb thermal energy, and their kinetic energy will increase, and they will flow from the hot end to the cold end of the metal base, and they will collide the atoms of the metal there, and they will make them vibrate vigorously. In this way, the energy is transferred to the free electrons. This process is also called free electron diffusion. It's a very important question, very, very frequently asked question. It will be a 3-mark question where you have to describe that how the conduction is happening through a solid metal. So you have to describe both the things. You have to describe the vibration of the particle of the metal, and you also have to describe the free electron diffusion. Do you understand? When you are done with your writing, kindly let me know. When you are done with your answer, kindly let us know. Shabash, shabash. Kindly, when you are done, kindly let us know. Today we are doing winter 2016 2-1 paper. Today we are solving its section B only. In this session, we are working on the section B of this paper. Yes, if you have written your answer.
सर समझा देंगे थोड़ा सा फिर
Molecules at hotter end absorb heat energy and they start vibrating. The amplitude of their vibration increases. They collide with their neighboring particles. They transfer energy and heat is circulated. These metal molecules also have free moving electrons. When molecules vibrate, they collide with electrons and they the electrons transfer through metal and heat is established.
Heat is established. Why are you saying heat is established? Heat
और
is transferred.
सर फिर से समझा दें ये क्वेश्चन
You see, there are two ways in which the conduction can take place. One is by the vibration of the molecules, and the other one is by the transfer of free electrons. You see, the molecules which are at the hot end, they absorb the thermal energy and they start vibrating vigorously. So their amplitude of vibration increases. They will collide with their neighboring molecules and they will make their neighboring molecules vibrate vigorously. So in this way, the energy through the vibration of the molecules will be transferred from the hot end to the cold end. Another way of doing this or explaining this thing is that the metals have free electrons in them. So the free electrons which are on the hot end, they will absorb thermal energy and their kinetic energy will increase and they will move from the hot end towards the cold end. And the electrons, the free electrons, they will collide with the molecules on the colder end and they will make them vibrate vigorously. So you see, the electrons have taken the energy from the hot end and they have transferred the energy to the cold end. This process is also called free electron diffusion. Kindly, if you have written your answer, Javeria, will you like to read that? It's a very important answer.
Okay, sir. May I
It will
read?
be coming in papers a lot, whether it's box or it's the actual paper in June.
May I read, sir?
Yes, yes, sure.
Because it is made up of metal, so it has free moving electrons. The molecules at hot end absorb thermal energy and start vibrating vigorously, and they will collide with their neighboring molecules and will make them vibrate vigorously also.
Okay. One sentence you missed is the amplitude of their vibration will increase.
Okay, sir.
Write that also.
Amplitude of their?
Vibration.
Okay. अगला करें सर.
Should we move? Okay, so let's move to the next question. He says, explain how the thermal energy spreads to all the oil in the pan. So oil is a liquid. So in the liquid, the energy is transferred by the convection currents. Okay. So what will happen? The oil, which is at the bottom, will absorb the heat and its particles will move away from each other. Its density will decrease and this less dense oil will rise upward and the dense oil will move or sink downward. In this way, the convection currents are set in, and this is how the energy will be spread in all the oil. Will you able to write this answer?
Yes, sir.
Okay, go on, write it.
सर मुझे आपकी आवाज़ नहीं आ रही.
You see, in the convection currents, in the oil, the heat is transferred by the help of convection currents. So the oil at the bottom, it absorbs the thermal energy and its particles move away from each other. The oil becomes less dense. This less dense rises upward and the denser oil from the top sinks downward. This sets convection currents in the oil, and by the help of those convection currents, the heat is spread to all the oil. Can you hear now, Muskan?
Yes, sir.
Okay, so write your answer.
सर जब ऑयल अपवर्ड मूव करेगा उसके बाद क्या होगा?
The the dense oil from the top will sink downward. The less dense oil will move upward. This will set convection currents in the oil. And this is how by the help of convection currents, you will see the heat will spread to all the oil.
Done, sir.
Okay. So would you like to read your answer?
Yes, sir. The
Okay.
oil will absorb thermal energy and particles move away from each other. Oil become less dense and it move upwards. The dense will sink down. This will set convectional current in the oil through which heat is given to the oil.
The heat is spread to all the oil. The word
Okay.
is the heat will spread to all the oil. And another important thing, the you said the dense will sink. Say the dense oil will sink.
Okay, sir.
May I read?
Yes, yes, yes.
The hot oil near the hot end of the pan absorbs the heat energy, so less dense oil rises up and denser oil will sink down. This sets convection current in the oil. By the help of these convection currents, heat will spread to all oil.
Okay. So you see, Muskan, listen carefully. The the oil at the bottom absorbs thermal energy. Its particles move away from each other, and this oil becomes less dense. And that less dense oil moves upward. The dense oil from the top sinks downward, and this sets convection currents in the oil. And with the help of the convection currents, the thermal energy is spread to all the oil.
Okay, sir.
Heated hot oil expands, becomes less dense, and rises. Convection currents, the circulation is established. Okay, this is a 2 mark explanation, very important. Muskan, you understand?
Yes, sir.
Okay, so the third part is suggest and explain a suitable material for the handle of the pan. You have to suggest and you also have to explain. The handle of the pan should be made of, let's say, plastic, because the plastic is an insulator, and it will not burn your hand. Let me show you the marking scheme. Three part. The marking scheme is showing. Kindly write this answer. Once you
Sir,
have done
done.
it.
May I read?
Yeah.
We will use plastic as it is a good insulator and it will not burn our hand.
Okay. Good. 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 We are moving to the next part. The specific heat capacity of the oil is 2 joules per gram per degree centigrade. The oil is heated from 20 degrees centigrade to its boiling point of 260 degrees centigrade. State what is meant by the boiling point. Boiling point. Boiling point is the specific temperature on which a liquid is converted into gas. Boiling point is a specific temperature on which a liquid converts from liquid state to gaseous state. It's a 1 mark definition, very famous definition. The marking scheme is showing on the screen. temperature at which a liquid vaporizes or becomes gas or becomes steam.
Done, sir. May I read?
Yes, yes, please.
Boiling point is a specific temperature in which liquid is converted to liquid state to gaseous state.
Okay. I have just got a very minor mistake in this definition. The temperature in which, you don't say in which, you say at which.
Okay, sir.
Okay. So the next question, calculate the thermal energy needed to heat the 680, you know, 680 grams of oil. So it's very simple. You know that the formula, when the temperature changes, the formula is heat is equals to mc delta theta. Mc delta theta. So it will be something like m, that's 680 gram, and you will multiply it with c, the value of the specific heat capacity, that is 2 joules per gram per degree centigrade. That's 2. Okay. So multiply it with the change in the temperature, q delta theta. I wrote q, but it is actually delta theta. So delta theta means change in temperature. The temperature changes from 20 to 260. So the how much is the change in temperature? 260 minus 20. So the change in temperature is basically 240. Just multiply them. You have calculator with you?
Yes, sir.
Okay, so what's the answer? 680 multiply 2 multiply 240 equals to
2,64,000.
what? 2,64,000 joule. This much energy is needed. Let me check the marking scheme. What is your answer?
32,64,000.
32. 32.
Same answer.
Is this the answer which is showing on your screen?
Yes, sir.
Okay, so it will be you need to read the joules also. In the standard form it will be 3.3 expo 6 joules. 3.3 expo 6 joules. Let me check the, but he says 3.3 expo 5 joules. Something is wrong. I added one extra zero, I think.
Yes, sir.
Let me take out my calculator. So you see, we say 680, you multiply it with 2, you multiply it with the 240, and the answer will be 326400. So in the standard form, if I write it in the standard form, it will be 3.3 expo 5 joules. 3.3 expo 5 joules. Do you understand this formula?
Yes, sir.
Devaria, better never forget this formula. Whenever there is a change in the temperature, we use this formula. Heat is equals to mc delta theta.
Okay. Delta theta is change in temperature.
Yes, for example, in this question, the temperature changed from 20 to 260. So the change in temperature is 260 minus 20. 240 is the change in temperature. C stands for
Okay.
the specific heat capacity, and M stands for the mass of the liquid.
Okay, sir.
Okay. So that was a 2-mark numerical. Okay, it's third part. It's 1-mark question. He says suggest one reason why the energy output from the hot plate when heating the oil is larger than the value calculated in the C second part. The energy which the hot plate is providing not all its thermal energy is going into that pan. Some of its energy is also going to the surrounding air. So that energy is lost. So that's why the energy which is provided by the hot plate will be larger than the energy which we just calculated. Write this answer. Another reason he wrote is that some energy goes into the pan, not into the oil. When you
May
are
I
done
read?
with this, yes, yes, please, Betik.
Not all energy is going to the pan, some energy is going to the air also.
Yes, yes. So, my dear students, so by that part, we have reached the end of that paper. Today, we have done October, November 2016 2-1 paper. And in this session, we have done its section B. In the section B, we have done question number 9, question number 10, and question number 11. So, I hopefully today it was a very so no. So we have done question number 10, question number 9, and question number 8. By mistake, I said question number 11. So in the section B, uh, there was question number 8, question number 9, and question number 10, which we have done. So thank you very much, everybody. It was a great session. I hope that this session is very useful to you. It will help you in improving your grades and improving your concepts. My name is Farhan Mazhar, and today is 19th February 2021. I was with the 11 Cambridge class. We also call it O3. The subject we were studying was Physics 5054. So thank you very much and have a good day. God bless you all.